All right, let's look at these bottom two examples here. These are a little bit different because notice either one of these we did not have a decimal in the one we were dividing by. Both of these new ones we have a decimal in the one we are dividing by. So that changes things a little bit. Okay, so let's look at these and see what we need to do. So again, a good estimate on this one. Just so you can get a good estimate, I would just do something as simple as 10 divided by 5, just because I know I could do that one really quick. So my estimate would be 10 divided by 5, and that I know. So my answer is going to be somewhere around 2. Now I really rounded that one up, rounded this one down quite a bit. So since I rounded that one up and this one down, I should be fairly close. But I know my answer is going to be close to 2. Okay, so let's just go ahead. And when you're dealing with ones like this, if you don't want to worry about the decimals, you don't have to put them in there. But again, the one I'm dividing by goes out front. So I'm going to put the decimals in there, and we'll worry. But just don't worry about the decimals when you're dividing them out. And we'll talk about that in just a minute, what we can do with these. Let's just look at this as one number, 57 and 912. So how many times does 57 go into, it doesn't go into 9, it does go into 91, it goes into 91 one time, doesn't it? So, and that is 57. So 91 minus 57 to borrow there, so that becomes 8. There would be 11, so that would end up with, we subtract those down, that's going to give us 4 and 3. 8 minus 5 would be 3, and then we need to bring down our 2. So how many times does 57 go into 342? This 42 is a key. I know that 7 times 6 is 42. Luckily 5, so 5 times 6 is 30, and since it'd be 5 times 50 really, so we end up with that since it's, so 6 times 7, so let's just do that over here to make sure. 57, I'm just treating it like it's numbers, not worrying about the decimals. So that would be 42, so put down the 2, carry the 4. 5 times 6 is 30, plus 4 would be 34. Yep. So that would be 342. Minus that down, we end up with 0 there. So then we ask ourselves, where can we put the decimal to get it close to 2? And really, we could put this decimal anywhere. We could put it anywhere out here, anywhere. But really, the closest we can get to 2 is a 1.6. That's the closest we can get to 2 is a 1.6. Notice this decimal has moved over once, and I have one decimal here. The reason is we want to get rid of this decimal out front here. The way we do that is if we multiply both these by 10, if you think of these as fractions, 5.7, I'm going to put it in a, because division, can be written as fractions, 9.12. If you think of these as fractions and we multiply them both by 10 over 10 at what we call a giant 1, that doesn't change the value of a fraction because 10 over 10 is 1. But what that does is that would change that to 91.2 and that to 57. So now we don't have a decimal in it. So if we move this decimal over to get rid of the one in front of that one, we move this one over, and then it would still line up. But we can use estimation to figure out where our decimal would be, because the only thing that would be close to 2 is 1.6. 16 is not close to 2. 0.16 is not really close to 2. So you have to kind of figure those out with estimations, see where you can get with these. So that's what you can do. Let's do one more here, okay? So let's estimate on this one. A lot of times when I'm estimating, I like to look right here. 64 is not a multiple of 3, but I know 63 is a multiple of 7. So if I change this to like 63 and divided that by 7, because 63 divided by 7 I know is 9. So that tells me my answer is going to be close to 9. And I didn't change those numbers that much, so should be fairly close to 9. Let's try this. So if we were to multiply both those by 10, that would move this one over to there, and that would move this one over to there, so we won't have a number out there. So we would have 73 out front, and here we would have 649.7. So how many times is 73? It doesn't go into 6, doesn't go into 4. 600 and so we got to figure out how many times it goes into 649. Take a little bit of trial and error. It's going to be less than. I would just try something like maybe 5 or something to see how many times it goes into that. 5 times would be 35. Well, it would be probably higher than that. I just look at the first, how many times 7 goes in there. 9 would be close to, we know that it's 63, so let's try 8. So let's go over here. 73 times 8. So 8 times 3 is 24. Put down the 4. Carry the 2. 7 times 6 is, 7 times 8 is 54, or 56 plus the 2 would be 58. There we go. So that's as close as we're going to get, isn't it? Because it's not going to be, so this would be 8. That would be 584. We're going to minus that down. See what we get. That's going to give us a 5. We got to borrow here. That's going to give us a 6. We bring our 7 down. I know that times it by 9 is going to give me something that ends with a 7, so that's probably what I would try. Let's just try that over here and see. So 73 times 9 is, that's going to end with a 7, carry my 2. 9 times 7 is 63, plus 2 would be 65. Yep. Okay, so put a 9 in there. That'd be 657. Slice that down. We end up with 0. Now, look right here. We know our answer has to be close to 9. The only way we can get it close to 9 is 8.9 is the only place we could get it to be close to 9 is 8.9. Notice that did line up if we move those decimals over to get this decimal over. And the way we can move those decimals over is by multiplying by 10. If you had to move it over 2 times, you'd multiply them. But whatever you multiply it by 100 really, but whatever you move this one over, you got to move that one over the same amount. That's the one you're dividing by that you need to move over. All right, if you have any questions with these, let me know. Keep practicing with these. There'll be some con and some IXL if you need practice with these to keep working through these. Good luck and let me know. Have a good day. Bye.